Hi students, here's the review for Spiral 8. I'd like to remind you to please take a look at this review and try to complete this before your spiral. This video is designed to help you on that path, and if you complete the spiral review, you can use that on your spiral as well as a resource. So this is a really good way to do well on your next spiral. Alright, first up we got to find some measures of each angle. And what we're trying to do here is to figure out what's going on if I have an angle that's going in a negative direction and it's going almost all the way halfway around a circle, but it's stopping pi over 4 before we get there. I know that if I were going to here, that would be pi. Since I'm going to pi over 4 less than that, this would be 3 pi over 4, because it's 1/4 less than a whole. And since we're going in this direction, it's going to be negative as our value. For the next one, we're going around in a positive direction, and I stopped when I got to this vertical axis because I know this is going to be 3 pi over 2. And if we're going pi over 4 beyond that, I could say this is 3 pi over 2 plus pi over 4. Okay, I need a common denominator, so that'd be 6 pi over 4 rather, plus 1 pi over 4 is going to be 7 pi over 4. And that's good for that. I'd also like you to notice that I included the, I don't want to move that whole thing, the unit circle on there. You can move it on your screen, I can't move it on mine, but that gives you some angles to kind of work with and shows you where the angles are in terms of pi, if that's something that you're struggling with. For the next part, we're trying to find the reference angle. That's going to be the angle made with the x-axis in each of these places. I'm going to draw those angles in first, just so that we see that in all 4 of these, we're trying to figure out the angle that's made with the x-axis. And then we're going to think about what's going on here. So this first one tells us that we're going 135 degrees in the negative direction to get to here. We know that going all of the way to the x-axis would be negative 180. So we've got to figure out how many more degrees are in here. This is like saying if we had 180 minus 135, what would we have left? And we'd have 45 degrees. That's our reference angle. This angle here would be 45 degrees. Just as a reminder, reference angles are always positive. All right, for the second one, we've got an angle that goes around a couple times. So we've got going around once, that's going to be negative 360. And then we've got going around half a time, that's going to be another 180, so that's negative 540, plus another 90 is going to be negative 630. So I'm going to say up to here, we got negative 630. If we want to get to negative 650, we've got 20 more degrees here, but that's not the angle I want. I want the angle with the x-axis, and if this is 90 in total, if we got 20 here, that's got to be 70 degrees. 70 degrees is my reference angle. For the next one, we've got 23 pi over 6 in the negative direction, and I want to think about this in terms of wholes. One really good way to think about dealing with radians and reference angles is to think about this based on making this into what is not an improper fraction. So if I have 23 pi over 6, and I know this is negative, I'm going to hold off on that for just a minute. Looking at this in terms of saying, okay, well, I know that 6 goes in 3 times to 23, because 24 would be 4 times. So I could even just say, okay, well, a 24 pi over 6 would be 4 pi. That's 2 full cycles. So if this is 2 full cycles, we got 1, 2, we can see that we're a little bit less than that. And to get from 24 pi to 23 pi, we'd say this is minus pi over 6, because we're taking 1/6 away from 24/6. This reference angle is going to be pi over 6. For the next one, we've got negative 29 pi over 12. I want to think about this the same way I just did the last one, which is that we've got really 2, which is going to be 2 pi, because that's 24 pi over 12. And then we've got 5 pi over 12 left over. So we could call this 2 pi plus 5 pi over 12. And when we do that, that tells us that, okay, well, there's our 2 pi. What's left over is that 5 pi over 12. Because this is a reference angle, that's got to be positive, even though we're going in a negative direction. All right, for each of these, we've got to find one positive and one negative coterminal angle. I did not mean to have you also figure out these angles, but I guess that's the problems that I selected as the base for these, so that's okay. Looking at the first one, we've got 180, and if we got 60 at the end of this, we got another 30, so this would be 210 degrees as the angle itself. A positive coterminal angle would be adding 360 to this, and when we do that, we've got 570 degrees. A negative coterminal angle would be subtracting 360 until we end up with a negative number, and when we do that, I get negative 150 degrees. That would be my positive and my negative coterminal angle. We're going to do the same thing, but we're going to do this in terms of radians. So we've got pi here, and we've got pi plus 5 pi over 12. And this is going to be in the negative direction. So I'm going to convert this to say we've got negative 12 pi over 12 and 5 pi over 12, which gives us negative 17 pi over 12 as our angle. To get this in a positive direction, I'm going to try adding 2 pi to this. So negative 17 pi over 12 plus 2 pi, which I could rewrite as 24 pi over 12, because that ends up being 2 pi. When I do that, I've got 7 pi over 12 as my final answer for that. Going in the negative direction, I can do the same thing, but negative 17 pi over 12 minus 24 pi over 12. And when I do that, I've got negative 41 pi over 12. For doing some trigonometry in a circle, we got to find the exact value of each of these things. I put a unit circle to the right so that you can use that as a reference. For secant, I know it's going to be the reciprocal of cosine because those are reciprocals of each other. They go with the wrong letter. So the secant goes with cosine. Cosecant would go with sine. So if I take a look, I see only another secant. I'm going to write cosine on top of that one as well. We've got to figure out where this angle is, and we've got to figure out what the reference angle for this is. The reference angle for these are all pretty easy. They're all going to be based on our denominator. So we're looking for the reference angle, and that's going to be pi over 3. If I find cosine of pi over 3, I am most of the way through this problem. Pi over 3 is here. Cosine is going to be the x value, so that's going to give us 1/2. In order to figure out what the secant value is, I've got to find where this angle is. And I know that 3 goes into 13 pi 4 times, so we could say that this is going to be 4 pi, that's 2 full times around the circle, plus pi over 3. So let's think about that. So this is saying this is going 1, that's 2 pi, 4 pi, and then that much further. So we're going to be in the first quadrant. Everything is going to be positive. So I'm just going to write positive, positive here, so I remember that for myself. And secant is the reciprocal of this, so I'm going to say secant of 13 pi over 3 is going to be the reciprocal of 1/2, so it's going to be 2 over 1. We're doing the same thing for secant of 3 pi over 4. I've got that angle on my unit circle. Cosine is negative root 2 over 2. So I'm going to say 3 pi over 4 is going to be negative root 2 over 2. Secant for this is going to be 2 over negative root 2. If you want to simplify that, you can. It comes out to be negative the square root of 2, or you could leave it like that. Cotangent of 2 pi. Well, I know if tangent of a function, we call it theta, is going to be y over x, that means that cotangent of an angle is going to be x over y. Okay, so let's find 2 pi. That's going to be going all the way around my circle. I'm going to do my x coordinate divide by my y coordinate, which is 1 over 0, That's undefined. We can't divide by 0. Sine of 13 pi over 4. We don't have to do any reciprocal stuff because we've got sine. I know that this is going to be based on a reference angle of pi over 4 because I see that's over 4. So my trig value is going to be root 2 over 2. What I have to figure out is if this is positive or negative, and I'm going to do that based on knowing where this angle is. So 13 pi over 4 is the same as saying, well, we've got 3 pi, because that's going to be 12 pi over 4, and then that's going to be plus 1 more pi over 4. So let's think about where that is. We've got 1, 2 pi, there's my 3 pi, and that extra pi over 4 is going to put me down here. In this quadrant, we've got negative x and negative y. Since sine is y, this is going to be negative root 2 over 2. Just going to erase my spirally thing so we can use that again if we need to. For cosine of pi over 4, that's one that's already on my unit circle. Cosine is the x value. That's going to be equal to the square root of 2 over 2. For sine of 5 pi, I'm going to start counting by pi's here. So we've got 1 pi going around, 2 pi, 3 pi, 4 pi, 5 pi. There's my values I'm looking at. Sine is y. The y there is going to be 0. For graphing sine and cosine, we have some steps that we're going to do for this. The first thing I need to do on all of these, and I'm really regretting putting these graphs in there, so I'm actually going to get rid of them entirely. Hopefully this works. And move that a little bit. That's perfect. Yeah, I don't want those graphs there. I'm going to build my own on your spiral. You will not have graphs. It's much easier if you were just given axes for this. So the first thing I'm going to do is identify my midline. And that's going to be at 2 above the x-axis. Cool. Then I'm going to identify my amplitude, so that's 4. I'm going to go up 1, 2, 3, 4. I'm going to go down 1, 2, 3, 4. And those are going to be my amplitude lines. Cosine is a graph that starts at the top, goes down, comes back to the top at the end of its period. My midline goes through like that. And now I'm ready to kind of figure out some of those points. So I'm going to find my starting point by saying 2 theta plus pi over 3 is equal to 0. I'm going to subtract pi over 3 to the other side. So we've got 2 theta is equal to negative pi over 3. And then I'm going to divide both sides by 2, which is the same as multiplying by 1/2, to get theta is equal to negative pi over 6. That's my starting value here. So I'm going to go to my x-axis. Just going to mark that as negative pi over 6. And for cosine, that's going to be at the top of my function. I'm going to do the same thing, but now I'm going to find the ending point. So 2 theta plus pi over 3 is equal to 2 pi. I'm going to be a little bit sneaky. Instead of 2 pi, I'm going to call this 6 pi over 3. Because if I divide that, I get 2 pi as an answer. I'm going to minus pi over 3 to the other side to get 2 theta is equal to 5 pi over 3. I'm going to divide by 2. And when I do that, I've got theta is equal to 5 pi over 6. So that might be somewhere at the end of your graph, 5 pi over 6. Cosine will be back at the top there. Exactly between these two, between negative 1 and 5, is going to be the value 2. So I'm going to say this is 2 pi over 6. And that's going to be cosine is at its bottom point. Exactly between those two, so I'm going to say between those lovely numbers, between negative 1 and 2, we end up being at 0.5. I'm going to do a not great math teacher thing and describe this as 0.5 pi over 6. We could also describe that as pi over 12, but I wanted to just kind of make that point that this is going to be on the midline. Same thing for the other one. We've got 5 and 2 gives us 7, so the average is 3.5. Again, not great math teacher stuff in terms of fractions that have decimals as part of those, but you could do that as 7 pi over 12 as well. There's our other midline point. We've got our graph. For the next one, we're doing cosine again. So again, we're going to have this type of shape. We've got a midline of -2. Amplitude here is 1. So I'm going to go 1 above that and 1 below that. And then I'm going to set up my beginning and end thing. So we've got theta minus 5 pi over 4 is equal to 0. That gives me theta is 5 pi over 4. Just going to put that here, 5 pi over 4. All right, then we're going to have theta minus 5 pi over 4 is going to be 2 pi, which I'm going to sneakily change to be 8 pi over 4, so we get 2 out of that. If I add 5, I get theta is equal to 13 pi over 4. So that's going to go here, 13 pi over 4. And now I'm going to start putting my points on my graph. Both beginning and end points should be at the top. So that's the upper amplitude point. Exactly between those, we're going to have 9. So that's going to be 9 pi over 4. Exactly between 9 and 13 is going to be 11. So 11 pi over 4. That's going to be on the midline. And between 5 and 9 is going to be 7 pi over 4. That's going to be on the midline as well. So we get our graph that looks like this. We've got 2 more to look at. The next one is going to be cosine as well. We also have these lovely things that, again, I'm going to ditch because I don't want them here. So let's take a look. We're going to have cosine. We know that looks like this. Our midline's out front this time, which is a little bit sneaky. So I'm going to put that midline in. My amplitude, I'm going to go up 2, draw my upper bar, go down 1, 2, draw my lower bar, and begin finding these things. We've got theta over 3 plus 2 pi over 3 is equal to 0. That gives us theta over 3 is equal to negative 2 pi over 3. Multiplying by 3, we get theta is negative 2 pi. Cool, so that's going to be somewhere back here, negative 2 pi. I'm going to do the same thing on the other side and try to figure this out as theta over 3 plus 2 pi over 3 is going to be 2 pi. I'm going to be very, very sneaky and make this 6 pi over 3 so that when I subtract this, I get 4 pi over 3 is equal to theta over 3. And when I multiply, we get theta is 4 pi. Just for the sake of scale, I'm going to move this guy a little bit to the right. So we got negative 2 pi. And that way when I have 4 pi over here, we can have positive 2 pi in the middle. And the scale makes some sense there. I know I'm also going to need to do some adjusting in terms of stuff. So we've got 0 between those two. We're going to have a 1 pi and a negative 1 pi here, and we're going to have a 3 pi there. All right, let's do our graph here. So we've got our 2 endpoints. That's going to be at 4 pi and at negative 2 pi. Exactly between those two is going to be at 1 pi, and exactly between the two on the right would be at 3.5 pi, and between the ones on the left, that's going from 1 to negative 2, so that would be at negative 0.5 pi. Our graph is going to look like this. For the last one, we've got sine. We know sine has a curve that looks like this. We're going to go down 1 for our midline, and go 2 above and 2 below to get our amplitude points. All right, let's get our starting point. I'm going to use x instead of theta this time, just for funsies. So we get x over 2 plus 3 pi over 4 is equal to 0. Solving that is going to give us x is equal to negative 3 pi over 4 times 2, which is negative 3 pi over 2. So I'm going to put that somewhere here. So negative 3 pi over 2. All right, then we got x over 2 plus 3 pi over 4 equals 2 pi. I'm going to write that as 8 pi over 4. So when we do some solving, we get x is equal to 5 pi over 4 times 2 is 5 pi over 2. So it's going to be on this side. Since this is sine, those points are both going to be on my midline. I'm going to go exactly between those two. 5 and negative 3 gives me 2. Half of that would be 1 pi over 2. That's also going to be on my midline. Going for the top point, between 1 and negative 3 is going to be negative 1 pi over 2. That's going to be my upper point, and then my bottom point between 1 and 5 is going to be 3 pi over 2. That's going to be my lower point. So we get a nice sine curve. Lastly, we got to do some identities. The goal here is to make one side look like the other. And a pretty good place for us to begin on this might be to try to rewrite these things in terms of sine and cosine. I know that cotangent, this is cotangent squared, is going to be cosine over sine. And since I've got two of those, I'm going to spread them out for just a minute. So do cosine over sine times cosine over sine. That's for cotangent squared of x. The other thing I'm going to do in this first step is to take a look at cosine on the bottom. And I'm going to rewrite this as multiplied by 1 over cosine of x. So that way we can see that we're going to cancel out one of the cosines. And when we do that, we're left with cosine x on top. In the bottom, we've got sine squared of x, which is what we were trying to get in the first place. For the next one, I'm going to start the same exact way. I'm going to rewrite this as 1 over sine squared x for cosecant squared of x. And I'm just going to keep the cosine as is. I'm going to spread this out a little bit, so it's going to become 1 over sine of x times 1 over sine of x times cosine of x, which I can combine those two to say that this is going to be 1 over sine of x times cosine of x over sine of x. We already said that cosine of x over sine of x is equal to cotangent of x. And we've got 1 over sine of x holding steady there. That gives us cotangent of x over sine of x, which is what we're trying to do for this problem. For the next one, we've got both cotangent and cosecant going on there. We may be able to combine some stuff there using some Pythagorean things, so let's take a look at that. We know that we have the Pythagorean identity, sine squared x plus cosine squared x is equal to 1. If I divide both of these things by cosine squared of x, by both I mean all three, we get tangent squared of x plus 1 is equal to, and that's going to be secant squared of x. Okay, that's not helpful because I was trying to get cotangent or cosecant. I don't see either of those there. So I should have divided by sine instead, which would have given us 1 plus cotangent squared of x is equal to cosecant squared of x. Now I see that I've got something that's in this problem. I've got cosecant squared of x. Let's make some sense of this. We've got cotangent squared of x minus the whole thing 1 plus cotangent squared of x. And that's over tangent of x. I'd like you to notice that cotangent squared minus cotangent squared leaves us with minus 1 on top. And now we've got, I like how I put tan instead of tan x. now we've ended up with something that we can use the reciprocal identity to say that this is the same thing as negative cotangent of x, which is what we're trying to get at the beginning of the problem. All right, for our last identity, I'm going to start off by, again, switching things to sine and cosine. I generally do that if I don't see stuff that's squared on the left side. That's going to help us out a lot. And when we do that, we've got cosine of x minus sine x over cosine of x. And then on the bottom, we're going to have 1 over cosine of x. That's a little bit tricky to work with, so one thing that I could do would be to rewrite this as a multiplication problem, where instead of dividing by 1 over cosine of x, we're going to multiply by cosine of x over 1. That gives us cosine squared of x minus sine x cosine x over cosine x. Those parts reduce, and we're left with cosine squared of x minus sine of x.